Welcome to the Archer tutorial. You're going to see how easy it is to make your graphic dynamic and that it just takes 3 basic steps. The first step is of course to assign the graphic. This is going to be the exact same vector graphic that will be brought to life in the next step. Let's speed things up a little bit. You see Adobe Illustrator here, but you are free to use any vector graphics tool that can export SVG files. For our example, we select a basic rev meter that you might know from your car. The needle shall be rotated based on the revolutions per minute. Let's say it's not an automatic but a stick shift, and a warning signal shall be shown when it's time to switch to a higher gear, and it shall turn red when the motor damage is near. There are a couple of tricks to prepare the graphic and ways to make your life easier when you work in the Archer editor, but we leave that for another tutorial. Just one thing to consider. Those elements and groups to be animated shall have an ID because you handle them in Archer projects. Now that the graphic is ready, we can start to make it dynamic with Archer. Let's create a new project and give it a name. This name is used as a folder name within your Archer projects path. Just pick any folder on your drive. An Archer project always requires an SVG file, so we directly import the vector graphic during the creation process. In the background, this graphic is copied into the projects folder, so your original file won't be modified. And here it is, the graphic in Archer. Just the way it was designed, including the SVG tree with nodes and the name you gave to the elements. For example, needle or alert. Let's start and get the needle to rotate. Select the needle and click on the rotate transformation in the functions bar. Now here's one interesting thing. Archer asks you to add it to a context. A context is always bound to a variable that can be for either a number, text or boolean. In our example, we pick number because the revolutions per minute can go from 0 to 8000. Archer opens a new tab in the context editor section. Here, several elements with their transformations are grouped together and all of it reacts to the variable value that is assigned to the context. For instance, the needle could get its value from a sensor, and this is referred to the variable name RPM. In the context editor section, you have a triangle on the left and on the right side. These keyframes are the indicators for overall value range. In our case, it goes from 0 to 8000. So we select the right keyframe and type in 8000 as value. Below, you have the needle with the transformation rotate. Now that the right keyframe is selected, you can click and drag the needle to rotate. Well, that's not the rotation we expected. Archer can do better. Let's reset. Now let's zoom in and get us the registration point for the rotation. A click in the inspector helps, and from there you can drag the point to where it belongs. Perfect. That looks much better. Rotate until the endpoint of 8000 RPM. You can also type in numeric values for higher precision. Now select the left keyframe. You also just saw the red line move. This is the scrubber. Just drag it and you can visualize the rotation between the value ranges. The rotation angle for the starting point can be set the same way. You could also skip the rotation and just type the angle. Here it's negative to rotate left. When you type in a value without a selected keyframe, the scrubber goes to that value and you can add another keyframe. This allows you to add additional values between the overall boundaries. In our case, we want to show the alert sign when it's time to switch gears, let's say at 4800 RPM. So you select the alert element, add it as a new node to the same context as the needle, and then you add an opacity transformation to it. You immediately see that the opacity is 100% along the whole value range. Click on the little triangle with the plus symbol to add another keyframe where the scrubber is. Now we go back to the 0 RPM keyframe and modify the opacity to 0. Archer automatically applies a linear interpolation to the values from one boundary to the other. So here the opacity will automatically rise to 100% when you have 4800 RPM. That is not really what we want. We said that the alert sign shall appear at 4800. So in order to do that, we need to double-click on the triangle to switch between interpolation and discrete values. You notice that the line between the keyframe disappears. So the opacity value stays at 0 and at 4800 immediately switches to 100%. Remember that we said we wanted the alert sign turn red when the RPM goes even higher? This can be done with an additional transformation to the alert element, the fill color. Say at 7000 RPM, the alert should turn red. Move the scrubber to 7000, add another keyframe and pick the color you want to have. Just like for the opacity, Archer automatically adds a linear interpolation for the color. And because the end value's color is still on yellow, the alert goes from yellow to red, back to yellow. Let's set the color to red as well. And we're done. Save. And export the project to see how we can add it to our web application. Now we continue with the third and last step of our tutorial. Here we have a plain and simple HTML page, where we will show you how to get your dynamic graphic working. Remember, for the example to really work, you need to run that page from within a file server. Simply opening the page in a browser from the file system won't work, as the Archer runtime tries to load the graphic from the local file system, which thankfully is prevented by the browser for security reasons. We don't show you how to set up a server in this tutorial. Please check out documentation for details. We create a container for our graphic, apply an identifier and give it some basic styles. Next, we need to import the Archer runtime library. You can find this file in the libs folder of your Archer export. Then, create a reference to the container element in which to display the graphic. And initialize it as a new Archer instance. Now we load the graphic and configuration file into the Archer runtime. The configuration file is also generated when you export the Archer project. Here we use the ready event to wait until everything is loaded. The Archer runtime allows a couple of viewpoint manipulations. For a start, we set the view for the graphic to fit the container. See if that works. Yes, graphic loaded and zoomed to fit the window. It's time to get started with manipulating our graphic. Set the RPM variable to Let's say 3500. Reload, and you see the needle correctly at 3500. Set it to 5500 and you would expect the alert element displayed. Great. Seems to work fine. To illustrate the dynamic display of the graphic, we could go one step further and include some interaction. In this example, we use the mouse pointer movement as input for the RPM. Simply set the RPM variable to the graphic, and now the needle and the alert symbol move as defined in the Archer editor. I hope you liked the tutorial. Please view our documentation pages for details and do not hesitate to email us for questions, issues and feature requests. Thank you very much and hope you have a good weekend.